So now we're going to get into the first consideration of what we can do with our enthalpy, because enthalpy is a state function. So Hess's law. Now, sometimes we want to know the delta H of a reaction, but maybe we can't do a specific reaction directly, but we can do other reactions stepwise. And so Hess's law lets us look at those stepwise reactions, manipulate them, and then figure out what our overall delta H of reaction is. So what we're going to do is we're going to look at these individual steps. Again, state function, path independent. So it doesn't matter if I took 2 steps or 12 steps or whatever to get there. What matters is that I got to that final state. So what we do is we identify our target equation. We're going to manipulate our stepwise equations so that they will sum up to our target equation. And then all we have to do is sum up our delta H. The important thing is whatever we do to an equation, we do to delta H, okay? So whatever we do to an equation, we do to delta H. So if we flip the equation around, we flip the sign of delta H. If we multiply the equation by something, we multiply delta H, okay? All right. So again, we're just going to look at that change in enthalpy is just the enthalpy changes of the individual steps. Okay, so here I have a process where I want to know what the delta H of the sublimation of ice to water vapor is. Okay, so I've got some stepwise equations. So our target here is our water in the solid form to our water in the gaseous form. Okay, so that's our target. Now when I look at this, liquid and liquid cancel out. Everything's at 1. Do I need to do anything fancy here? No. This one's easy. We're just going to sum those up. I'm going to give myself a little bit more room though. All right, so our delta H of reaction is just going to be the delta H of that first process plus the delta H of that second process. So we're going to get 6.02 kilojoules for the first reaction plus 40.7 kilojoules for that second reaction. And we're going to get 46.72 kilojoules for our target reaction. Okay? All right. Now let's try another one. Okay. So I want to know the enthalpy change for this solid carbon, okay, to methane. So I have my target equation. So I need to look at my stepwise equations and figure out how to manipulate them. So here I have carbon on the reactant side, giving me methane on the product side. So my first reaction, I have carbon on the product side and some other stuff that doesn't matter. My carbon's on the reactant side, so I'm going to leave that one alone. Now, in my next one, I've got some hydrogen gas. In my target equation, I do have hydrogen gas. However, I need 2 hydrogen gases. So what I'm going to do to this entire thing is I'm going to multiply it by 2. Okay? Now, in my target equation, I need methane as a product. In my third reaction, I have methane as a reactant. So what I'm going to need to do here is I'm going to need to, I'll put it on the side, twist it around. Okay? All right, so let's see how that looks. So we have equation, and then we're going to have delta H in kilojoules. Okay, so I have my first equation, which I left alone. Okay, and I got negative 393.5. Hey, now my second equation, we multiplied it by 2. So everything gets multiplied by 2. So I had 1 hydrogen, so now I have 2. I had 1/2 oxygen, so now I have 1. And I had 1 water, so now I get 2. Okay, my delta H was negative 285.8. I needed to multiply that by 2, so I get negative 571.6. Okay, now my last reaction, I didn't multiply it, but I inverted it. All right, so my carbon dioxide and my waters went to my reactant side. Okay, and my methane and my oxygen went to my product side. All right, now the delta H given for that reaction was negative 890.3. Because we inverted the reaction, we have to invert the delta H. So we're going to get positive 890.3. All right, now before I sum up my delta H values, I'm going to make sure that I did this all correctly and I do get my target equation. All right, so here I've got an oxygen on the reactant side and 2 oxygens on the product side. I have another oxygen. I'll get rid of that. Okay, here I have a carbon dioxide on the product side and a carbon dioxide on the reactant side. Okay, and then I have 2 waters and 2 waters. So remember, our target equation was a solid carbon plus 2 hydrogen gas gives us methane. So let's see here. Did we do okay? So I have 2 hydrogen gas left. I have a solid carbon, and I have methane. All right, well, looks like we did everything correct. And so we can go ahead and just sum up these. And when you sum these up, you get negative 74.8. Okay? All right, now this next one is going to be for you to try. All right? I will give you the final delta H. It's going to be negative 297 kilojoules. All right? So figure out what you need to do with both of these equations. Make sure that they sum up to the target equation, and then check to see if you get the same delta H that I did. All right? But again, you got to try these on your own. You will never learn it if you only copy down what other people are doing. You have to struggle with it. Learning is a struggle. It's a productive struggle because you are learning something, but it is a struggle and it is hard. And there are times when you are just like, I don't know why I'm doing this, but you do it and you get through it. Okay? So try it. It didn't stop. Let me try this again. Try the problem.